Okay, here's some example problems, similar but slightly different. So just meander your way through, ask questions if you have them. So this is from problem number 7 from your workbook on page 56. I've got it right here. I'll read it a little bit to you. So this is a problem. It says at time t seconds, the height h of a ball thrown vertically upward, so you just chuck a ball, is modeled by the equation h equals, right here. About how long, this is the question they want, but I'm going to throw a couple different questions at you because your homework's going to have that sort of twist on it. So I'll give you a chance to kind of understand it before you dive in. So this says, about how long would it take the ball to hit the ground? So if we took a look at this, remember, h is height, t is time. We know that if we actually had like a graph, it would be here 0 seconds, and this would be like 1, 2, 3, 4, 5, 6. We're going to throw it up, and it's going to come down. Now, don't think that I drew the picture accurately. All I'm saying is there are two places where the height is 0, right here and right here. See, these are our zeros. There are x-intercepts. That's why they're so significant in these story problems. So we're going to say, hey, that kind of triggers our thought process. We have to set h equal to 0. So 0 equals negative 5t squared plus 33t plus 4. Now, the nice thing about the quadratic formula is we're going to solve for t. It's going to tell us t is 0 for one of them, and then because it's where you threw the ball, and it's going to tell us the other one. So here it comes, negative b plus or minus the square root of b squared, that's going to be a little nasty, minus 4 times a times c all over 2a, which is negative 10. Now just so you know, you could multiply this all by a negative 1, and then that will change everything, but you'll still get the same answer, so don't worry about that. I got to get my calculator here a second. All right, got my calculator, did a little crunching. 33 squared is 1,089. This times this times this is just positive 80. So if we kept going, we'd get negative 33 plus or minus the square root of whatever that would be, 1,169 all over negative 10. Now, we're going to have to crunch this out. We've got to be able to take the square root of 1,169. Let me do that real quick. All right, I got to stay close to the calculator here. So I added those together, got the square root of 1,169, which ends up being 34.2. I rounded it just a little bit. So we're going to crunch this out now. What's negative 33 plus 34.2? Well, that would be 1.2. But that'd be over negative 10. As you can see, we get a negative time. Remember, we're solving for t, which stands for time, and you can't have that. So we go the other route. Negative 33 minus 34.2 is negative 67.2 all over negative 10. Now, these two negatives would cancel. And 67.2 divided by 10, I should have been able to do that in my head, is 6.72 seconds. And there's part 1 of this question. I'm going to erase this so I have room to kind of work here. Okay, so think about that. 6.72 seconds I was thinking about as far as an NFL punter. Those guys can boom it. 6.72 seconds. They'd be in the NFL for sure. They'd be hitting the top of, Ford Field. Okay, there we go. I was going to say Silverdome. All right, question number 1. Does the ball reach a height of 10? Does it? Well, we're going to stick 10 in for this. We're going to take a look. 10 equals negative 5t squared plus 33t plus 4. You're going to have to deal with some weird stuff. So now we have a problem, and they're asking, does it? So if something mathematically impossible happens, we go, nope. But if something mathematically possible happens, we go, yeah. So this is where the discriminant is going to come and help us, okay? So we're going to subtract 10, subtract 10. We're going to shove this stuff into the quadratic formula, just the discriminant part. So we get 0 is negative 5t squared plus 33t minus 6. Here's my A. My A is here, my B is here, my C is here. All I care about is this portion, b squared minus 4ac. Because they're just saying yes or no question. Nothing specific, no details. So if I plug stuff in where it belongs, my b squared is 33 minus 4 times a, which is negative 5, times c, which is negative 6. This is supposed to be b squared. Okay, I have it on my calculator. Let me find it. All right, I found it, plugged it in, 1089. I went 4 times 5 times 6 is 120, because there's 3 negatives. I know it's going to be a minus. And I can just look at that and say, yeah, that's going to be the square root of some pretty good-sized positive answer, so that's a real solution. So yes, the ball definitely reaches a height of 10 meters. Now what if they ask 100? How does that change the problem? Well, then we go back to this, and instead of 10, we're going to stick in 100. Now, let me erase this. And now I go through the same process. Subtract 100, subtract 100. 0 equals negative 5t squared plus 33t minus 96. So here's my A, here's my B, here's my new C. So I'm concerned about the discriminant part. So b squared is 1089. For some reason I can't seem to remember that. Yep, okay, I guess I did. So that's b squared minus 4 times a times c. Now look what's about to happen. So I get the square root of 1089. Negative, negative, negative is going to give me minus. I don't know what 20 times 96 is. Give me a second. So you can see that this times this times this is going to be minus 1920. Well, this minus this, we don't need to know exactly what it is. We can just see it's the square root of a negative. It's not possible, which means the height is not possible. So interesting math and how it applies to real life situations.